Welcome, welcome. We are going to hop straight into it. We are on day 16. And this is going to be our data training part 2. And what we did last was put in this code all down here, which got us working with printing out the sensor that's being passed into the node, into this layer, and then the output that should be, and then functionally um, finding out the loss afterwards using the optimizer, getting the logits, etc., etc. So today we're gonna kind of walk backwards and really go in depth about what's going on here, how it's working, and then from there, depending on how much time we got left, we'll look into. We should be able to fill out all of this pretty much, what the model's doing, what the loss and optimizer are doing in this exact functionality here. So first and foremost, I want to take another look at this next iteration for the data loader. Um, so first, let's do this. Or let's take this off. Let's get rid of this. So first, I want to understand what exactly is happening with this training data loader. Actually, no. You want to start up here, don't we? So model, right? This model equals models.resnet 18, right? So by selecting model.resnet 18, what is our default, right? I want to understand what is this giving us by default that's saving us time. So then I can understand fully what's missing by not having it and what we gain by having it. Oh, man. Alright. So you're choosing the ResNet 18 architecture, which is 18 layers deep. So that to me is you're working 18 layers of convolution layers that are finding the pixels and the patterns and shapes, etc., until it builds up a full-on structure. Convolutional network, neural network, the CNN, designed for image data, which is what we're going to be working with. This fixes the number of layers, layer types, where ReLU is applied, which is the non-linearity function. Where batch norm live, skip connections exist. You're not designing the network anymore, you're accepting it. So this is the activation function. Loss function is not included. Function that maps input to logits. It does not define cost function, optimizer learning rate. Okay. By default in most frameworks, final layer equals linear, output equals logits, not probabilities. This implies you're expected to pair it with cross entropy loss. Softmax is usually applied to decide the loss, not the model. So ResNet 18 plus cross entropy loss gets you your actual probability. Weights are essentially randomized or initialized by K-mean initialization. Bias is set to 0. Input assumptions. Image input, RGB values normalized. Okay. All right. So ResNet needs RLUU because an activation function is needed when um, getting input. Why is an activation function needed though? I know it's needed, but I don't remember why. And then two, break down what changes when you swap the final layer for transfer learning. I don't know. To me, breaking down, swapping the final layer, I know the output needs to be different because now we're outputting towards the two options of receiver and cornerback on the final layer. Um, I don't think I know what transfer learning is. That's the first thing. Circling the right idea. Without an activation function, a neural network, no matter how deep, is just a single linear equation. A layer without activation does this. Output equals mx, y equals mx plus b. It's a straight line. Yep. Now stack two of them. Algebra collapses into w something x plus b. So just one. I guess it all collapses back down to y equals mx plus b. I see. So it can't do all the different, which language are all non-linear. No, no, it literally cannot represent the problem. Its derivative is simple, which we figured out how to figure out dealing with as it approaches to zero, as h approaches to zero, right? Okay. All right. So we're choosing the ResNet 18 model. So what attributes does a model have? So the model is going to have weights and biases. It's going to have layers. It'll have the architecture of how the data flows, the activation functions are being used. Um, gradients. With structure, state, rule for how the data flows. So all in all, the model is how this data is going to flow. How will this picture of a receiver flow into the output of whether it's the cornerback or receiver? That is what this model dot ResNet is doing. So from there, now we're saying model dot FC is what? To me, if I remember correctly, this is the final layer, right? So we're saying in regards to the final layer of this model, set it up to be like this. Is the final fully collected linear layer of the model. In ResNet 18 specifically is the 18th layer, right? That turns learned image features into the final output scores. Convolutions plus RALUs, residual blocks assume the job of feature extraction. which is going to find whether your forward lean, your foot separation, things like that. At the end, the image has been compressed into a feature vector. Maps the feature vector, outputs values. So feature vector is to me the final of the forward lean of the foot separation, right? For ResNet 18, out features the default shape. So by default, there's 512 learned features, outputs 1,000 logits. Logits, not probabilities. That means no softmax inside. You're expected to use cross entropy loss, which applies softmax internally. Okay. So this final layer is just going to produce logits. And then after those logits are produced, then you're using cross entropy loss, which is handling the softmax of this logit, which is just normalization, right? Which is going to do the normalization for the end result of this final layer, handle the softmax, and then apply the cost function to it to get your final score. Right? So everything before FC extracts features, FC learns how to map those features to your labels. So I have num classes, which I'm getting from the training data.classes, which is up here, which is coming from the root uh, folder of the training dir, which is up here, which gives me the two directories inside of cornerback receiver, which is how I get the num classes because we're getting the length of the array of num classes, and we could also print out num classes is the number of the length of that array, and then also what class is, it'll just print out that array for me. So from there, you have your, like I said, the models. This model is going to be off ResNet 18, which has 1,000 outputs normally, but we're going to just have it reduced to 2 for the final layer. So however it wants to work in the between, in the middle, is up to it. Um, but then we're saying the neural network, the final layer, is going to intake as many features as the final layer is supposed to intake, and then output just 2, because that just happens to be what we're doing. Okay. So what is model equals model dot to device? Moves the model's tensors to the device you specify. That's the whole action. Every parameter buffer copies them to device, which is going to be CPU. So when you often see, because dot two returns a model reference, that guarantees you keep the moved version. Okay. Set to CPU. Model dot parameters device. This is me printing out what device we're on. Okay. So now we don't need this. So now we understand that. So now let's understand does what. Let's figure out what's happening here. Give me the first item from X. Right? Ask X for an iterator, something you can pull items from one by one. Pull the next item for that iterator. Since it's a brand new iterator, the next item is the first item. So I see. Your first batch, often label input labels. So if I said X and Y. Let's print X. Ah, would you look at that? So, what is happening here? I have no clue. My hypothesis would be this is something to do like with the tensors, right? And these are each of the layers. But that 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30. 30 times 390. That doesn't sound right. I don't know. We'll see. What is actually going on right here? What is happening? It's related to the tensors. It's an image batch. Almost certainly, after transforms normalization, the structure tensor means it's four-dimensional. Batch size, channels, height, width, repeated per image. What the exact numbers per X shape. So I have a batch of 5, RGB, and then the height and the width. I see. So I get the batch size, right? If we're saying this is batch size, and then we're saying this is the resolution. Resolution, x dot d type, right? The value range, x dot min dot item, and then x. Should I do like these x dot max dot item, and then print current device, which we know is going to be CPU. Start device. Let's take a look at that. Okay, so we get the value ranges, we get the resolution. There's still something missing from my understanding though, because we get this batch, but what if I want to look at one specific thing inside of that batch, right? So you get the batch size, 5 images at once, 3 channels per image, and this is where it starts, right? So from here, you get more layers done onto one image after you pop out that image. Yep. Your final layer must output 2 logits, which is what it's doing on the num classes here. And then after you after that calculation, then you do what's next. Models do math in floats, not ints. Okay. 5 exceed 1, max is negative 2.6, and max is 2.6, minimum is negative 2.1. If you didn't normalize, training would be unstable. So this right here is what I needed to do to make it normalize. So this training data can then go into the training loader, which will then work with the batch. Training will work, but slower. The current pre-processed batch 5 normalized RGB image size for ResNet 18, ready for binary classification using cross entropy. Noise. So run one forward pass. So you're saying, okay, outputs equals model inputs. Where are we getting inputs from? Right. You loop through it. Okay. So in PyTorch, you'd usually do something like a loop for X, Y, and data loader. Um, or you do the next iteration of data loader inputs label. So X, Y. So I essentially have this. So I need to do output model X and then print X dot shape. But it's the same exact thing as that. Do I need to do 2 passes on it? Outputs equals models, inputs being X, which is the tensor to the picture of that batch. X inputs is entire source, creates an iterator over your data loader, pulls the first batch, yep, is using a tuple, image plus labels. So X is literally whatever your data sets get item returns as an image after transformation collected into a batch. With the model too, but you did not move X to the same device before. I see. So I need to move X to the device. So X equals 2 or dot to device. X to device. And then we'll do Y as well just to be sure. And now let's see what happens. Still the same output. Ah, basic programming problem there. Okay, so now I get 5, 2. So what is this? Is the something in regards to the first picture, right? The shape, break it down. 5 equals batch size. You passed in 5, 3, 2, 4, 2, 2, 4. So you give the model 5 images at once. The model produces one output per image. So the first dimension stays 5, 2. Number of classes equals 2. So for each image, the model outputs two numbers for a single image. Oh, by shape, it's like shape of the, is it shape of the graph essentially? Not graph, of the matrix, right? So if I print outputs 1, let's say 0. Ah, I see. So you have the tensor of, okay, okay, okay. Expects raw logic, applies softmax internally, compares against interchangeables. First, final mental model. So batch size, number of classes, 5 images with 2 class scores each. All right. So 5 images, 2 class scores on each image. So now I want to apply this. So I'm saying criterion equals neural network cross entropy loss function. That being said, though, what I do want to figure out is which I want to figure out which picture is being used, right? Um, uh, just I don't think none of the batch tensor. Data loader was built using dataset. Basically, training data loader equals dataset, and the files names are stored in dataset dot samples. Should be training data dot samples, path to entry, path to image, class index. I wrote my own dataset. I did not. So I guess I care less about even caring about what picture it is and more about what output should it be, right? I don't really care about whether this should be receiver or cornerback, right? That's not what I care about. What I care about is it accurate? one patch and compute outputs. So logits equal model of X, expect one entry. Okay. So step one. So let's try this out. Let's follow this and see if we can pull the output for what an entry should be. So you're starting first, you have your first chunk out of your data loader, and you're saying with torch, no grad. What is no gradient descent maybe? What is torch dot no grad? Don't track gradients for anything inside this block. Run the model, but don't build the computation that's needed for backprop. Change. Does forward computation only. Does not store intermediate tensors for backward. Does not compute grad. Less memory is faster. Okay. So after you do this, and we say with torch dot no gradient logits equals model of X, which is going to be that batch, right? And that batch is going to give us, um, it's going to provide the calculations on the images and provide us with outputs for the first five. Okay, so now predict class index shape is 5. Prediction logits dot rmax dim equals 1. Inspect one entry. So then you say I equals 0. Then let's just copy paste this output since we're not looking at actual code necessarily. And to me, you're saying why. I see, we're looking at the same exact output. So it's predicting 0. I mean, sorry, it's predicting 1. It's predicting receiver, but the label is really cornerback. And since the receiver number is bigger, I see. Okay, this time we got it right though. Got it right. Got it right. Am I crazy? Am I crazy or is this not what we're looking for? Am I crazy? For each run, you print two logits. Index of the larger score. Okay. Pred equals the index of the larger score, which will be 0 or 1. And then so you can say pred 0, y 0. Okay. Which is good though. I like the fact that it's changing means it's doing the prediction against multiple different pictures and oftentimes it's getting it right. Is giving you a different first batch each run, meaning different image and labels. That's why the truth label fits between zero. Yep, that's fine. Inference on training data with a model that has a pre-trained backbone, but a brand new FC threat weights. So early on, it's consistent, often wrong. That's expected. But in all, okay, okay, all right. So at the basics, though, at the basic level of it, it looks like first and foremost you have your model, all right, and then from your model you can input a data loader batch into it. Right, so it's getting my next iteration of from the data loader. I send the X and Y's to the CPU, and then I can pass that the the X the X's to the model, which will output logits and a matrix. And then from there, I can essentially determine which is it either cornerback or receiver based off of that. Or realistically, what I will be doing is using the cross entropy loss function and then have that handle the softmax and then the calculations for an actual real prediction. And from there, be able to do a bit more with it. So I think tomorrow we'll get into like handling the cross entropy loss function and things along those lines. And then the day after will be how to actually save the changes and make sure things are um, building as they should be. So let's do this. Let's make it simple. Day 17, data training 3, which is going to be in regards to, what did I just say? This is going to be in regards to the cross entropy plus loss functions, activation functions. Question mark. Well, we already know that's getting set by the model itself. And then we'll come here to day 18 of data training 4. And this is going to be saving, training her, right? Updating, training weights. So this will be it actually learning. This is handling functions, loss functions, things like that, the cost. And then today was all about first training run, which we finally got done. So the model is, now that we understand, handles the architecture of the training activation, layers, outputs, etc. Okay. Um, yeah, I feel we took a large step forward today. Really actually got things working, got things running. So from here, it's normalization of the outputs, the logics, applying the softmax, actually getting the probabilities, and then after that, it'll be actually training, getting better and better at things, and making sure we're taking the time to take a look at this data that's never been looked at before, and check there, make sure there's any validation that needs to be done, etc., etc., etc. But appreciate y'all coming out. Hope y'all learned